On June 19, 2004, two astronomers at Kitt Peak National Observatory in Arizona were conducting a routine survey of the night sky. They were looking for near-Earth objects, asteroids, and comets whose orbits bring them close enough to our planet to warrant monitoring. They found one. It was a small, faint dot moving across their telescope's field of view. They logged it, assigned it a temporary designation, and moved on. Routine work. Nothing unusual. 6 months later, a team of astronomers ran calculations on that small dot's trajectory and produced a result so alarming that they checked it 3 times before publishing it. The asteroid, now formally designated 99,942 Apophis, had a 2.7% probability of striking Earth on April 13, 2029. That number does not sound large. But in the world of asteroid risk assessment, 2.7% is not a small number. It is not a rounding error or an instrument anomaly. It is a real, meaningful probability of a 340-meter wide asteroid, roughly the size of 3 football fields laid end to end, colliding with a populated planet within 25 years. Apophis instantly achieved the highest rating ever recorded on the Torino Impact Hazard Scale, a system developed by NASA to communicate asteroid risk to the public, scoring a level 4 out of 10. No asteroid before or since has scored that high. Scientists who study near-Earth objects described it publicly as the most significant asteroid threat ever detected. Then, over the following months and years, as more observations refined the trajectory, the probability came down. The 2029 impact was ruled out, then 2036, then 2068. In March 2021, after radar observations from the Goldstone Solar System radar allowed scientists to precisely map Apophis's orbit, NASA's Jet Propulsion Laboratory announced officially that Apophis has no chance of impacting Earth in the next 100 years. The threat is gone. The danger is over. But what remains is something that has never happened before in recorded human history and will not happen again for generations. On April 13, 2029, a 340-meter wide asteroid will pass closer to the surface of Earth than the satellites in our own orbit, and you will be able to watch it cross the sky with your naked eye. This is the story of Apophis, how it was found, what it once threatened, what it will do in 2029, and what the closest asteroid approach in recorded history means for how humanity understands its place in a solar system full of rocks in motion. To understand why Apophis matters, you first need to understand what it actually is and where it comes from. Apophis is a near-Earth asteroid, a member of a category of space rocks whose orbits around the Sun bring them into the inner solar system, crossing or approaching Earth's orbital path. It originated in the main asteroid belt between Mars and Jupiter, the broad band of rocky debris left over from the formation of the solar system roughly 4.6 billion years ago. Over millions of years, gravitational interactions with Jupiter and other large planets gradually perturbed its orbit, pulling it inward until it became what astronomers classify as an A10 asteroid, a type of near-Earth object whose orbit is slightly smaller than Earth's. Apophis is not a perfectly spherical rock. Radar imaging has revealed it has a peanut-like shape with 2 distinct lobes connected by a narrower midsection. It tumbles as it travels, rotating on its axis, while simultaneously wobbling in a more complex motion that makes precise measurement of its exact dimensions and composition challenging from Earth. Its longest axis is estimated at approximately 450 meters. It is gray-brown in color, made of silicate rock, similar in composition to ordinary chondrite meteorites, the most common type found on Earth's surface. It is, in other words, a fairly ordinary asteroid. There is nothing unusual or exotic about its composition, its origin, or its structure. What makes Apophis extraordinary is not what it is, but where it is going and when. When Apophis was first discovered in 2004, the initial probability calculations produced that alarming 2.7% impact figure for 2029. But as additional telescope data was gathered and fed into the orbital models, scientists also identified a secondary concern that would persist for much longer than the 2029 threat. During the 2029 close approach, Apophis will pass through a region of space around Earth known as a gravitational keyhole. A keyhole is not a physical object. It is a precisely calculated volume of space, in this case, roughly 800 kilometers in diameter, through which, if Apophis were to pass exactly, Earth's gravity would alter its subsequent orbit in such a way that the asteroid would be redirected onto a collision course with Earth exactly 7 years later, on April 13, 2036, the same date, 7 years on. April 13th is, for reasons of pure celestial mechanics, Apophis's recurring appointment with Earth's orbital path, and for several years after the asteroid's discovery, scientists could not rule out the possibility that the 2029 flyby would send it through that keyhole. Additional radar observations eventually reduced the probability of the 2036 impact to less than 1 in a million. The 2021 measurements effectively closed the book on the 2036 scenario entirely. But the keyhole concept itself remains one of the most sobering aspects of the Apophis story because it illustrates something important. The 2029 flyby is not just a spectacular astronomical event. It is an event that will physically change this asteroid. And those changes have consequences. When Apophis makes its close approach in 2029, it will come within approximately 32,000 kilometers of Earth's surface. To put that in perspective, the network of geosynchronous satellites orbiting Earth, including many of the satellites that power global communications, weather forecasting, and GPS navigation, orbit at an altitude of roughly 36,000 kilometers. Apophis will pass closer to Earth's surface than those satellites. At that distance, Earth's gravity becomes a significant force acting on the asteroid. Not enough to pull it in, but enough to do something that scientists are genuinely excited to observe and study in real time. Earth's gravity will stretch and compress Apophis as it passes. The side of the asteroid facing Earth will be pulled more strongly than the far side, creating tidal forces, similar in principle to the forces that create ocean tides on Earth. These tidal forces will likely trigger quakes on the asteroid's surface, cause landslides that reveal fresh material from beneath the surface, and alter the way the asteroid rotates on its axis. Apophis will enter the close approach tumbling one way, and emerge from it tumbling differently. The 2029 flyby will also permanently alter Apophis's orbit around the Sun. It will exit Earth's gravitational influence on a slightly different trajectory than it entered, reclassifying it from an A10 asteroid to an Apollo asteroid. The encounter will effectively change what kind of asteroid Apophis is. Scientists have never had the opportunity to observe this process happening to an asteroid of this size with advance notice. Every other close approach in history either went undetected until after it happened, was too distant to observe in sufficient detail, or involved objects too small to study meaningfully. Apophis is 340 meters wide. It is coming within 32,000 kilometers of Earth's surface, and humanity has known about it for 25 years. This is why space agencies around the world have mobilized resources unlike anything previously dedicated to observing a single close approach. NASA has redirected its OSIRIS-REx spacecraft, renamed OSIRIS Apex for its new mission, to rendezvous with Apophis during and after the 2029 flyby. OSIRIS-REx previously returned a sample of asteroid Bennu to Earth in September 2023, making it one of the most successful asteroid missions ever conducted. OSIRIS-APEX will arrive at Apophis in April 2029 and spend 18 months studying the asteroid up close, observing in real time how the close approach changes its surface, composition, and rotation. The European Space Agency is launching a separate spacecraft called RAMSES, the Rapid Apophis Mission for Space Safety, in April 2028. RAMSES will arrive at Apophis in February 2029, 2 months before the flyby, and will remain in orbit around the asteroid through the close approach and beyond, providing continuous observation of the event from directly alongside the asteroid itself. Both spacecraft will be studying Apophis at the same time, from different vantage points, while a network of ground-based and space-based telescopes observes simultaneously from Earth. The 2029 flyby is shaping up to be the most comprehensively observed asteroid event in human history. And then there is the aspect of this event that no scientific instrument can fully capture, because it has never needed to before. On the evening of April 13, 2029, people across the Eastern Hemisphere, from Europe and Africa through the Middle East and into Asia, will be able to go outside and look up at the night sky and see Apophis with their own eyes, no telescope required. It will appear as a moving point of light, crossing the sky over several hours, passing through the constellation Cancer before moving into Gemini. At its brightest, it will reach approximately magnitude 3.1 on the astronomical scale, making it comparable in brightness to some of the stars in the Big Dipper. Hundreds of millions of people will be in a position to observe it simply by stepping outside on a clear night. Nothing like this has been seen in recorded human history. Halley's Comet, the most famous periodic visitor to the inner solar system, is visible to the naked eye approximately every 75 years, and is much larger than Apophis, but typically far more distant. An asteroid of Apophis's size, known in advance passing this close, has simply never happened before in the era when humans could track such things. The last time an asteroid came this close to Earth without anyone knowing about it was almost certainly prehistoric. What does Apophis tell us about the broader picture of asteroid risk? The story of Apophis, from its alarming 2004 discovery through the gradual refinement of its orbit and the eventual ruling out of impact, is in many ways a success story for planetary defense. The detection systems that found it worked. The mathematical models that assessed its risk worked. The additional observations that allowed scientists to rule out the impact worked. Humanity found a significant threat with 25 years of warning, assessed it carefully, and determined it was not going to hit us. But planetary defense scientists are careful to point out that the Apophis story also illustrates the limits of current capabilities. Apophis was large enough, and its orbit unusual enough, that it was detected during a routine survey. But scientists estimate there are thousands of near-Earth objects of similar size whose orbits have not yet been fully mapped, and potentially hundreds of thousands of smaller objects capable of causing significant regional destruction that have never been detected at all. The 2013 Chelyabinsk meteor, which exploded over Russia with the force of roughly 30 times the Hiroshima bomb and injured over 1,500 people, was approximately 20 meters wide. It was not detected before it entered Earth's atmosphere. Scientists had no warning at all. Apophis, at 340 meters, would cause destruction on an incomparably larger scale if it were to impact Earth. Scientists at the Planetary Society estimate it would cause widespread destruction across an area several hundred kilometers from its impact point. If it struck a populated region, the death toll could reach into the millions. If it struck the ocean, it would generate a tsunami capable of affecting coastlines across an entire ocean basin. None of that is going to happen on April 13, 2029. The science is clear on this. Apophis will pass safely, be studied extensively, and continue on its new, slightly altered orbit around the Sun, but it will pass closer than our own satellites. It will be visible to the naked eye across half the planet, and the scientists watching it with spacecraft alongside will be learning things about near-Earth asteroids that simply cannot be learned any other way. April 13th, 2029 is a Friday. If you are in Europe, Africa, the Middle East, or Asia, and the sky is clear that night, you can go outside and watch a mountain-sized rock pass through the space between Earth and its own satellites. You will be watching the closest approach of an asteroid of this size that humans have ever been aware of in advance. You will be watching two spacecraft orbit alongside it. You will be watching something that has not happened in human history and will not happen again for generations. You will also, if you know the full story of Apophis, understand that the 25 years between that faint dot on a telescope screen in Arizona in 2004 and the night sky in 2029 represent something genuinely remarkable. Humanity saw it coming. Humanity tracked it precisely enough to determine it was safe. And humanity will be ready, with cameras and instruments and spacecraft, to learn everything it possibly can from the encounter. The asteroid named after the Egyptian god of chaos and destruction will pass by in the night, and for the first time in history, we will all be watching. That is Apophis. If you want to go deeper on the events and phenomena shaping our world and our solar system, subscribe to Horizon Archives. We'll see you next time.